Hello. We are out, guys. Derek. So, hello for the last final day of Vector Hack talks. This time again from 4 cities all around the world. First with us is James Lehman from, where are you in Ohio?
I'm in Akron, Ohio. Yes.
Akron, Ohio. Chris King in London and Derek Holzer in Stockholm. Okay. And I'm in Dubrovnik. We have a last day of physical vector hack with the
tour of the premises is there, Klif.
Yeah, it's
oh, there's the Polaroids. Are those the real Polaroids now?
Yeah, well, they're not real. They're, I mean, developed photos, but it's the real photos that we were supposed to show arrived yesterday to Zagreb by post office. It took a month instead of
the glorious U.S. Postal Service for the
also Croatian Postal Services. Okay. Thank you very much. But we'll keep those photos. It's one of the loose ends of this festival, along with the laser projections by David Francis, who just didn't happen because of some technical problems. So we'll realize them at some later slots this year.
And these Polaroids are by Evan Henry, is that correct?
Evan Henry, and they're really nice. I mean, this is the part that will have to get its dedicated video along with the laser work by Sofia Udiskaya, because in this crowded program we didn't really have enough time to present those works. So this is just a sneak preview of what Evan did. Hi, Evan.
Right, and those are Polaroid captures from Vectrex. Is that correct?
Vectrex, yeah.
Yeah. No, it was really nice to see those come in as part of the open call there. It's a really nice take on the format a little bit. I have myself around some pieces of a Polaroid camera that were also used to photograph oscilloscopes and things like that. But of course, the film for that camera is long gone. It doesn't exist anymore. So I kept the hood and I jettisoned the rest. But yeah, it's really nice, and it's let's say historically correct way of working with the medium. Actually, this is the way that if you saw photographs in scientific experiments or analog computer displays or things on these oscilloscopes, then you had to use a photographic camera, and they developed these special Polaroid cameras specifically for that purpose. They have the one that I had at least had a fixed focus. It was only
only for
fixed focus was exactly as long as the hood. So if you tried to aim it at anything else, it was just it was completely fuzzed out.
Did it have a gun at the end, like a
handle? It had a little handle like a trigger. It looked like some sort of weird James Bond weapon when you so that was cool. A friend of mine in Helsinki has that particular piece of gear now, and I have no idea what he's going to do with it. We have 2 videos that are coming up. The second video is going to be a walk through the world of James Lehman, some of his artistic background and influences, and a walk through the very multicolored, rainbow-hued world of LaserBoy. Before that, we have the other James. We have James Nolan Gandy. Gandy unfortunately could not join us today and sent a somewhat incomplete video. He had unfortunately some very serious crisis in the family, for which we want to send him a lot of support and thanks for his generosity in giving us a video in the first place in the middle of these say very difficult times for him, and send him support to manage the things that he has to manage right now. But what we will show is a 15-minute, essentially kind of a video slideshow of his work. Some background on Gandy is that, I'm going to pull up the cheat sheet here for a second. Where did I put the cheat sheet? There we go. James grew up in Florida, and he has a background as a machinist. He's been working on before he started making the drawing machines that we're going to see images and footage from in the video slideshow. He was responsible for making machinery to work on furniture and different sorts of furnishings and large scale things. So he has a background not just creating objects, but creating machines to make objects. And he some of the earlier stuff that I found, at least on his blog and his post, goes back to about 2016. But I suspect that he started a bit earlier. And he started building these very elaborate, intricate drawing machines. And as you'll see in the video, the machines themselves are these handmade works of art with these incredible, very precision gears and pulley systems in order to manipulate several parameters. There's a turning platter where the paper that's being drawn on is set down. And then on top of that, there's a number of pulleys that manipulate an arm which holds a pen or a pencil or something like that. And he's worked with lots of different kinds of papers. Some of my favorite things that he's been working on lately is to use this kind of fluorescent ink in the pens and to show us images of the drawings under black lights, and they're very, very surreal, very beautiful stuff. Not quite sure what else I can say at the moment. Although one thing that I do want to do is connect Gandy's work, which is very contemporary, and this is an ongoing practice. He has a very wonderful Instagram that you can see all of his stuff on, with more historical practitioners. There was certainly a lot of plotter art that we saw on some of the earlier presentations. And Chris, help me out. Gentlemen in the UK using parts of anti-aircraft guns and bomb computers to make drawing machines just after the Second World War.
Yes. Harry, what's his name? I love his work.
Yeah.
But yeah, he used the gun computer just like John Whitney.
Yeah. Yeah. And John, the work of John Whitney Sr. and his brother, James as well, also used parts that were salvaged in the Whitney's case from an analog computer that was used to calculate gun trajectories to be able to shoot down incoming aircraft. And in the case of the British gentleman, who's Chris is looking up right now, he actually used the aerial counterpart to that. This British gentleman started finding parts of the machines that set the bomb site calculators in order to precisely drop a bomb on something. He started finding bits of those in like military depots and junkyards and things like that, and use those to construct these amazing motorized drawing machines that sometimes kind of shook themselves apart. One of his drawing machines toured around with the famous cybernetic serendipity exhibition that was curated by Yasa Reichert in the late 1960s, and I think probably broke down several times during the course of the exhibition. If we don't have his name ready to hand right now, we can pop back in with that a little bit later.
Mine, but it's on the tip of my tongue.
In any case, Gandy's work connects a lot with historical drawing machines, and also with some of the earliest things that were used to generate Lissajous figures, which were harmonographs, basically not motorized drawing machines that used weighted pendulums of different ratios to kind of move a table around and use a pencil on that table to draw.
Desmond Paul Henry.
Desmond Paul Henry, yes, Desmond Paul Henry, working from the 40s, 50s, and 60s with bomb site calculators from aerial bombing planes to make these incredible drawing machines. So the history of drawing machines is quite long, and of course it starts with these kind of harmonographs and also the experiments of Lissajous himself, who used mirrors mounted on tuning forks to project a beam of light. Let's say maybe the very first like laser display, right, in a very physical sort of a sense. Chris, you had something? No?
No, I was just going to say, I guess also Benjamin, who joined us, talked about his father, who's rhythmograms, Heinrich Heidesberger, are very linked to that practice too.
Absolutely, yes. Yeah, another historical practitioner. In that case, working with light, exposing a light basically on the end of a swinging pendulum, exposing a photographic plate or a sheet of photo paper mounted underneath this also incredibly elaborate hand-built sculptures. So it's a pity that we don't have James Gandy to talk to us today. I hope we've done some justice in contextualizing his practice through linking it to some practitioners in our program and also some historical figures that we talked about during the first Vector Hack as well. Without further ado, Klif, I'm going to ask you to run the tape. Thanks so much for joining us.
So that people understand the technical problem with Gandy's video is that it's missing sound. So we have a 15-minute silent film. It's still beautiful, and we hope to release the full movie once we get it from James. So enjoy.
So turn on another channel of sound and kick back.
Yeah. Streaming.
Hi, I'm James Lehman, and I'm the guy that wrote LaserBoy. LaserBoy is something that I started on about 17 years ago, and at the time it was just some code that I put together in order to complete a project that I had in front of me, and that was to make a laser show for First Night Akron 2004, which is the New Year's Eve celebration. And I had about 2 months to do it. So I'm a Linux programmer, and I had already spent a considerable amount of time working on another project called EasyFB, which is an API written in C that gives a programmer complete access to the video card in a Linux machine. It gives you the RAM, you can put images directly into the RAM, and you can control what's on the screen in real time. So writing code for Laser was actually something that worked really well for me at that time, because I could use my EasyFB frame buffer API along with writing the code that would become LaserBoy, and the two of them worked together very nicely, and I was able to develop both of them at the same time. Well, it turns out that the way memory is stored in a video card that puts the picture on the screen is pretty much exactly the same way as an image is stored in a bitmap file. It's just one's in the memory in the video card, one or the other one is you put a header on it, store it to a file, and you have a bitmap file. So I had quite a bit of code that knew how to deal with bitmap files, reading them and writing them and managing them and drawing pixels into them and lines and so on. So I used that capability to build LaserBoy. And originally, LaserBoy was actually a console application. I would have two computers. One was running Linux with a high-resolution video display with my frame buffer API controlling the video display. And then another computer I would use to shell into the Linux machine at a command prompt or a terminal, and I would issue my commands in the command prompt and make the high-resolution video display show me what I was working with. So first thing I did was I wrote code that made it possible for me to open up the contents of any ILDA file. And an ILDA file is a set of frames. Each frame is a vector image, which might be color, could be two-dimensional or three-dimensional. The color might come from a palette or it might be direct RGB. And there can be any number of frames. Typically these frames make some sort of an animation. And the code that I wrote made it possible to open an ILDA file into the memory of the computer as a rather complex memory object. It could contain all of the frames, it can contain all of the palettes that are associated with those frames, and it gave me the ability to, well, have a state machine, which is once the data is loaded into the memory, it just sits there until you want to do something with it. And when you do something to it, you make some sort of incremental change to it, it becomes something else. So it's a static representation of an animated set of frames. It kind of exists outside of time. It's a very complex memory object. And when I had that, I was able to load anything that was already an ILDA file into the memory and use that as a starting point to create animations by moving elements around in a frame, or whatever the case may be. And then I was able to save that information as an ILDA file and open it up. And at that time, for the First Night Akron 2004 show, we were using a proprietary a proprietary laser controller card. It was actually an ISA card slot. And we recorded the output of that onto a modified ADAT machine. And that's when it all kind of made sense to me. That's when I fully understood what laser signals were all about, and that you could use an audio device to record them and play them back. So after the First Night Akron show was done, I just decided that I would continue working with this new art form of color laser display. And I knew, since I used an ADAT machine, that I was dealing with audio-like signals, so I extended the capabilities of the code that I had so that it would be able to read and write multi-channel wave files. And those multi-channel wave files could contain the optimized laser signals, which when sent to the projector would actually project the show that you created in a frame set. So for this whole wave idea to make sense, well, I knew I needed a piece of hardware that would be able to do that. So I looked in the Linux kernel driver, the kernel build configuration tool in the sound devices, and there were a couple of chipsets that were listed there that were 6-channel or 8-channel capable. So I looked for devices that had those chips on them, and I should say, started modifying sound cards and experimenting with the idea of making this work. And when I say we, I mean my friend Dean Hammonds and I, somebody that I've known since I think 6th or 7th grade. Anyway, he's pretty good with electronics and op amps and all that kind of stuff, and he came up with a very simple, very straightforward op amp circuit that could be used to compensate for the DC offset and provide gain to bring the voltage of the signal up to something that's compatible with a laser projector. So we started with his original design, and over a period of several years, things were modified. I've worked on it since then, and I came up with a circuit board that I printed. This is a LaserBoy DAC in that this is a USB sound device that's designed for surround sound. It's actually an 8-channel, 16-bit, 48 kilohertz DAC, and I tacked wires onto the DAC side of all the capacitors that block the DC from the analog outputs, and then I bring those signals into a correction amplifier, which is a few generations later than the original design that Dean Hammonds drew up back in, what was it, 2004, 2000, yeah, it would be sometime in 2004. But anyway, this is a LaserBoy DAC. It's still a sound card. I mean, that's exactly what it is. It is a sound card, and all of these jacks still work because they still have the capacitors in series with them, just like they should. But it also has an ILDA port on it, and you can use it to produce laser signals. LaserBoy actually defines a couple of file formats that are extensions of already existing file formats, and the whole idea of all of that is to keep it open source. It extends the concept of a WAV file. A WAV file is written as a chunk file system, which means that each chunk of a file has, there's a specific place where you find the size of the entire chunk so that you can skip the chunk if you don't know what it is. Which means you can add things to a WAV file that won't affect the ability for any other application to be able to read the WAV file and make use of it. So I use that to add information in the header of a WAV file that basically describes some things that you need to know in order to use that WAV file as a multi-channel signal set for laser control with X and Y, RGB, and possibly other things stored in the 6th channel or even the 7th and 8th channel. I also used binary markers in the color channels because the RGB channels are, you're only storing 256, well, you're storing 8 bits of information in a 16-bit number in a WAV file. So you have the least significant bits in the RGB channels to use to do something with, to mark something with. So I marked using the red channel, the least significant bit in the red channel designates the end of a frame, and the least significant bit in the green channel designates whether or not the frame is unique or has been repeated. And these things are actually stored in the LaserBoy formatted WAV, so that if you create a WAV file in LaserBoy and save it, then when you open it later from LaserBoy, LaserBoy knows how to read those format marks and can give you a completely framed set. I'd have to say it's just not possible for me to tell you what LaserBoy is in 30 minutes. I mean, if you download the application and you run it, and you take the time to explore what's in there, you'll get a sense of what it is and how much you can do with it. A lot of people think the user interface is a little weird, and yeah, I guess it is, being that it's all keyboard, but that's because LaserBoy started as a console application that would run in a shell, and the shell was connected to a Linux machine that was giving me the high resolution vector display. So the only thing I had to work with was a keyboard. And so as I was developing the code in the early stages, it wasn't for anyone in particular other than me. So I wrote menu systems, and I could keep the menus, show the menu in the terminal, and I knew what to hit next in order to make the LaserBoy core code, the memory object, do what I wanted it to do. Open file, save file, modify the contents of a file in the memory somehow, change the colors in the file, whatever it did, and save it, and then you were out, and you could use that ILDA file for some other purpose then. So I just kept developing it that way, and it kind of became a challenge to do it that way without using a mouse. And that's when I kind of discovered that there's a level of precision that you can achieve by using a keyboard as opposed to a mouse, because a mouse has the resolution of whatever the display is that you have on the screen that you can see of that vector set. But a keyboard, it has nothing to do with the resolution of the display that you see on the screen. The keyboard simply counts iterations of how many times you've hit a particular key. And that made it make sense to me that LaserBoy is a memory object, so it is a state machine. So an individual incremental change to the state machine could be achieved by tapping a key on the keyboard. And that's what LaserBoy does. It maintains whatever's in the memory for as long as you want it there until you want to change it in some incremental way. And you do that by tapping a key. Sometimes when you tap a key or a few keys, it'll ask you to type in a name of something or what have you. But for the most part, when you're working with LaserBoy, you're looking for a key in the menu system. There is some sense to whether it's the lowercase version or the uppercase version. There's also a logical sense when you're in certain menus. It's simply it's 0 through 9, and the alpha, A through Z in that order to choose something from the list. Sometimes it's logically the physical position of keys on the keyboard, because these 3 keys are in a row and these 3 keys are in a row. There's a lot of that is used. Sometimes it comes down to the logic use of things like X, Y, and Z on the keyboard, and left, right, up, down arrows and the delete key and the backspace key and that sort of thing. And the enter key is kind of weird, because the enter key typically makes the menus appear or disappear, unless in fact you're terminating when you have to enter a line of or string of text into LaserBoy at a prompt, and you hit return in order to enter that. But for the most part, the way the keyboard works definitely has sense to it. It is organized. There is kind of a zen to it. You do have to pay attention to context, because when you're in different menus, the same key might mean a completely different thing. So you really have to understand when you're in the main menu, or when you're in the color and blank and unblank and draw menu, or when you're in the move and scale and rotate menu, or when, various menus that you're in, the same key can do something different in all of those different menus. So you have to understand where you are in LaserBoy, and if you're ever confused, just start banging on the escape key until you see the screen flashing red, and you hit it one more time. When you see LaserBoy come back again, you know you're at the main menu, and from there you can go into any one of the menus where you think you ought to be, and then you know what the key does, because you can see, hit the enter key, you can see the key map on the screen, you can go, yeah, that's it, and you hit the key and use it. That's how LaserBoy works. It takes a while to get used to it, but when you do get used to it, it's actually very fast. It really is. If you put your mind to solving a particular task, and you, I guess, if you have to write it down, whatever you need to do, memorize a set of keystrokes, you can typically open a file and modify it in a very meaningful way and save it in not that many keystrokes, and it doesn't take that long to do it. So if in the process of doing that you mess up and you end up with junk loaded in the LaserBoy's memory, you just start again. You open up the file and you do the same click, 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 going through what it is that you need to do to modify it in order to get it ready to save it, and you can get there. So, I mean, when you are using LaserBoy, there is no undo. You have to remember that for sure. So it makes sense to save your file in stages. You know, you create a beginning piece of art and you go, okay, that's cool, that's where I want to be, and you save it. And then you modify it in some way and you go, all right, that's another step, and you save that. Or you know you need to make a set of individual things and you need to composite them together in some way. You have to save those things along the way so that you have a set of files that are saved all along the way, so that you don't have to keep starting at square zero every single time you want to. You know, maybe you did something in LaserBoy that you thought, oh, well, I didn't want to do that. Well, you got to start over again. So you have to have the file ready. You just open it again and you click, 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 click. All right, now I'm back to where I was. This time I'm going to do it a little bit differently. That's kind of how LaserBoy works. And the fact that it can only read and write into its own file space, well, it is an inconvenience. However, that's what makes it platform independent. It makes it easy for me to use Boost to write the code necessary to be able to read and write files on Windows or Linux or whatever, anything else that is pretty much supported by SDL2 and Boost. So yeah, I mean, it's kind of weird, but if you think about it, you could have an external USB storage device and you could have LaserBoy installed on that. And inside the LaserBoy folder, you can have a version of LaserBoy, the executable, that'll run in Linux or Windows 32-bit or Windows 64-bit or maybe on a Mac, hopefully soon, or some other operating system that, you know, maybe that you've never even heard of that is supported by SDL2 and Boost libs, the Boost C++ extensions. And you can just plug that USB drive into whatever computer platform it is that you've got, and you have exactly the same user interface to your file set, your data set, that's sitting right there in the same directory as all of the executables that make it work, that can be run on all the different operating systems that all give you the exact same interface. LaserBoy. LaserBoy probably does have a pretty steep learning curve, and it's hard to know why you would want to use LaserBoy until you really know what LaserBoy is and what LaserBoy can do. So hopefully, I think it's worth it to spend some time working with LaserBoy. And if you have questions, ask me. But if you use LaserBoy for a while and you get into it and you start to realize what it is and what it can do for you, then you can figure out how you can use that in your workflow, whatever it is that you're working on in vector space. So LaserBoy is a complex memory object. It's able to open the contents of any legitimate ILDA file into the memory of the computer, and then once it's loaded into the memory of the computer, it's able to display a view of that data set on a two-dimensional computer monitor in pixels. So you got vector data that's three-dimensional in space. You can look at it from any angle of rotation, anywhere you're looking at it, any direction you're looking at it from, and it'll render whatever's there. You can zoom into it, you can zoom out of it, you can pan left and right and up and down just by changing the camera settings, so to speak. But you can also change the data itself because you have the data in the RAM. It's dynamic. You can do whatever you want to do with it. And that's pretty much what LaserBoy lets you do. LaserBoy is open source software, which means all the source code comes with the distribution. And I guess if you know something about C++, you might want to look there, because it is the way LaserBoy works pretty much comes from C++, and the way it allows you to implement an object-oriented environment, a hierarchical set of objects, or coordinate and communicate with each other in the same space. Typically, when I start on a programming project, I like to start with absolutely nothing and build everything from the ground up. And that's kind of where LaserBoy started. I mean, I'd written all of the LaserBoy code, and I also wrote the API, EasyFB, that put LaserBoy into the video card. So, I mean, I literally wrote all of it except for the Linux kernel and the frame buffer support that it provides. And then somebody told me about SDL, which is a simple direct media layer, which is an API that's written predominantly for game developers, and it makes it possible to use a common interface to communicate to media devices like a keyboard, a joystick, a mouse, the monitor, a set of basic abstractions of things that you would find on any operating system. So you can write one set of code that communicates to the SDL interface, and then SDL handles the communication to whatever operating system it's actually running on. So that made it possible for me to write one set of code that I could compile, and people using Windows could use it, along with people who use Linux. What SDL gives me is the ability to open a window of a certain width and a certain height in pixels, and it gives me the address of the upper left-hand most pixel in that window. And I know that I can simply copy a bitmap that I've created in my code to that address, and it will appear on the screen inside the window. And that's true in all operating systems, which is, that's the beauty of SDL. It also gives me what key you hit on the keyboard, and whether or not you got the shift key down when you did that. And so I get keyboard events, and I know where to put the bitmap on the screen every time a keyboard event happens. And I also get timers, so that I can use whatever the system clock is to count milliseconds or microseconds within the code in order to do things like timed framed per second output when you're playing an animated set of frames and you expect them to show at a particular frame rate. Also, when you're playing a WAV file on the screen, it shows it to you at the same speed or the same rate it would appear if you were to be playing it into the sound card and into a laser projector. For me, LaserBoy is kind of like a place to go to. I can go there two ways. I can go there by looking at the code in a code editor, and I visualize what the code does in my mind, and I can alter it and add to it and fix it and find issues with it and fix them, or come up with a new idea and spend days and days figuring out how to implement that idea. And that's really what keeps me going is the discovery of new things to do in this space. That's kind of important to me. It's like a collection, really. When I started putting LaserBoy together, I thought, this is cool, I can do some really nice stuff with this. And then I just kept realizing, well, I could do this too, and then I could do this other thing, and if I do that, then I have this other stuff to do, and it has just kept going along. And one of the things that's really driven it is working with other people who have started to use it to do things, particularly with DXF import and DXF import of multiple frames to be able to use 3D CAD applications to render to DXF file and then open them in LaserBoy and sequence them, turn them into something that is actually usable as color laser vector art. And being able to read and write plain ASCII text files. When I work with other artists who have projects in mind that LaserBoy has in some way at least gotten close to solving for them, when we exchange files, we exchange conversation about what they want to do and how they want to do it, it always makes LaserBoy so much better. And there's been so many things that have been added to LaserBoy because various artists have contacted me and said, hey, okay, this does this, but I need it to do that. And then I would work on it, and I'd get something done, and I'd say, there, now it does that. And now LaserBoy does that for anyone who wants to do that. So LaserBoy does a lot of things, and it's interesting that it is simply in the realm of files in and out. You know, you might think that's a limitation, but it's not. It just puts the LaserBoy application in a particular domain of applications. Color laser projection, I think, fascinated me right away because I realized it was a combination of two things that I really, really enjoyed. I'm a musician and a recording artist, so I was already pretty used to the idea of working with WAV files and working with digital audio. I'm also a visual artist with a lot of experience in computer graphics and programming. And color laser display is actually a combination of both of those things. It's a set of signals that are very much like audio signals that create a color visual image. And that was fascinating to me. Those two things come together to become one thing. Back in late 2003 when I got involved with laser display, there weren't very many people working with it. Most of the people who were directly involved with laser display probably worked in the entertainment industry for some production company that toured with a band, or maybe in an amusement park that had a laser display. So it was a very esoteric art form at that time, and not very many people had ion gas lasers and optics tables and polychromatic acousto-optic modulators and scanners set up in their basement. A few people did, but not very many people. So I guess one of the reasons why I was attracted to it was because it was wide open. There were so many things I could do, but just hadn't been done yet. And so that was exciting, because I definitely like to come up with ideas, put it out there, and think, maybe I'm the first person that did this. I was born in late 1964, and I remember probably when I was about 10 years old, I was absolutely fascinated with the concept of a computer and what a computer was and what it did. And by the time I was 11 years old, I knew that I wanted to learn how to program in C, and I dreamt about working on a Unix computer, Unix mainframe. I mean, I'd seen the big stacks of printouts of the Snoopy calendars and all the cool stuff that you could do with computers, and I was absolutely fascinated by all of that. I got the Sinclair ZX81 that had 1K of RAM, and you could buy the 16K module that plugged into the back of it. And one of the first serious programs that I wrote was it would plot spirograph images, which is like a polar coordinate system thing, on the display, which was, by the way, it was 64 by 44 pixels on a television, black and white television monitor. And after that, I got a Commodore 64, and I pretty much did the same thing, except I had two colors to choose from on a 320 by 200 pixel screen. Same thing though, plotting polar coordinate equations or parametric line equations or what have you. The kind of thing that is essentially associated with vector graphics, coordinate systems. That's always been my interest in computers, and computer science is ways to use them to make art, to make designs, to create something visual or audible, whichever the case may be. I love math. I've always loved math, and I like to use math to find art. There's all kinds of infinite patterns and design possibilities for art that are deeply rooted in math. And working with three-dimensional vector coordinates in color, well, there's a lot of math going on there. So in LaserBoy, in C++, I defined a lot of my own data types, like the color, or the 3D short integer, or the vertex, or a list of vertices, or a list of colors, and all of these things, these objects, they have functions and arithmetic operators defined on them. So they all interact with each other in the realm of math. And with that math, I was able to discover how to do a lot of things that make it possible to convert three-dimensional color vector frame set into a working multi-channel wave file that could be used to control a color laser projector. It's not real time. You actually have to create the frame set in the memory, kind of like in a studio production sort of setting. You're making something that exists outside of time, and when you're done with the entire animated set, you can render it as a wave file, and then when you play the wave file, you get the laser show. So that's been my plan all along with LaserBoy. It's really never been a live streaming content environment. It's always been like a studio, a production tool to work with color laser vector art. I feel like if you use math to make art, the art has some kind of inherent proven substance to it. In other words, somehow or another, it becomes the solution set of whatever ideology or methodology went into it from a mathematical perspective. So it's a proof of concept. A finished piece works because mathematically it resolves. And that's kind of how I like to look at making art. So LaserBoy is art, the code is art, and the running application is art. And that's the perspective that I like to look at it from, is that this is my work of art, and it's a tool that allows other people to express themselves in this art form. Color laser vector display, or oscilloscope display, or vector video creation, or high resolution bitmap images of vector space. There's quite a few options, things that you can do in three-dimensional color vector space and its relationship to raster space using LaserBoy. And hopefully we can get enough of an overview of it.
And we're out. Hello, my apologies. I pressed the button for the for intro like 10 seconds before the end of James' lecture. One of the many hiccups with our stream, and now we're back live with James, Lehman, Derek, and Chris.
Perfect. Keeps people hungry just to like cut it off that little bit early.
Anyway, talk is available on James' excellent LaserBoy YouTube channel, and we'll be talking about all the tutorials that he put on there.
Do you have me? Audio?
Yes, we have you.
Hello, James. Thank you so much for joining us.
Oh, thank you so much for having me. This whole thing has been really exciting. I've really enjoyed every minute of it. It's awesome.
Thank you.
Thank you.
Yeah, thanks a lot, James. One thing that I picked up, and it's something that I was thinking about a lot earlier when I first came in contact with your software, and let's say the way in which one interacts with it. It's very interesting. quite a few of the people that we've invited, I think almost everybody that we've invited to talk on this this kind of conference section of the Vector Hack has been really actively involved in making their own tools. And I would say that quite a few of them make their own tools precisely because the tools to do the things that they have in their mind don't necessarily exist yet. And I think that some of that is definitely applicable to you. What was it in specific? I mean, I know you kind of gave us a very dense technical overview of it, but what was it about being able to place potentially animated laser graphics as memory objects? What or in a frame buffer? What was missing from that for you? Why did you need to invent this particular set of tools?
Oh, well, that's a good question. Pretty much from the very beginning of working with computers and art, I've always realized that in order to express myself, I have to find an environment where I can do that. I mean, whether it's you got to figure out how to get to the pixels, in other words, directly. And that's always been kind of a challenge. And so like when I first started, I had to figure out what was available, that I could use. And then when I got advanced enough in my programming abilities, then I was able to create the environment where I could manipulate what I was working with. So, well, let's see. In 2003, right about this time of year, this guy came to me and he says, "Hey, I'm putting together a laser projector and I want to do a show for First Night Akron. And, I know you know a lot about graphics and stuff. You want to help me with that?" And I'm like, all right. So, he brought over some stuff that he had. He had a laser control card and the software that went with that. And he also had that program called Anarchy. Have you ever heard of that one? Anyway, it's actually pretty nice. It's been around for a long time. And so I had Anarchy and I had the software that came with this proprietary laser controller card. And I also had a book that was written by this guy from Canada. His name is escaping me right now. It's not Robert, I believe his last name is. But anyway, he describes in the book that there's this thing called the OLDA file format, and here's basically what it is and how it works. And I thought, oh, all right, that's cool. So I started working with that, and I wrote code that I could open it and save it. And when I had it in the memory, then I could do things with it. I could manipulate the contents of it. And quite frankly, I was looking at the software that I had that came with this proprietary laser controller card, and I was just like, seriously, I can't do the stuff I want to do with this. It's just not here. So that's really what drove my development was, I just used that software that came with the card for really nothing else than to bring the OLDA in and be able to put it in a timeline editor kind of a thing and do minimal effects on it, and then clock that out through this proprietary DAC that the hardware piece of that, and then we recorded that on a modified ADAT machine, and which made it a lot more portable because we could take that to the location where the show was going to be coming from, which happened to be the roof of the Polymer Science Center. That's pretty much the core of the University of Akron. And we were on the roof of the building, and we were shooting right onto the front of the E.J. Thomas Performing Arts Hall. So it was a huge display area. It was pretty cool. It was really nice. We're using an ion argon, great big huge argon laser to do that. So that was it, really. It was just like, it was a matter of necessity. I mean, I was thinking, well, I know I want to do these things, and this software isn't getting me there. So that's why I wrote it.
Great. The world of laser display is it's probably come a long way since you started working on LaserBoy. And in a minute, maybe you can tell us a little bit where LaserBoy kind of fed into that development. But for the outsider, or for the person who is just coming into the laser world, The first thing that gets sometimes very aggressively peddled on you is a set of very industry standard proprietary hardware and software combinations of things, where not only is the software proprietary and the hardware proprietary, in other words, you need the software to address the specific hardware that this company has sold you as a package, but even the file formats are specific to that particular software package. And in some cases, I've even seen that content produced by some of these software packages is considered somehow the intellectual property of the software company that has helped you, produce this content. It's a very sticky mire of people trying to hold on to licenses for content, licenses for tools and things like that, which is, to my mind, really off-putting. But
Yeah.
how did LaserBoy kind of dovetail into this? Because you've mentioned online in a few places that some of the LaserBoy code has been taken up by some of these other packages.
Well, okay, I don't know. Well, yeah, that's hard to say because I mean, I keep my head down and I just grind on LaserBoy. I don't really worry too much about other stuff that's out there, especially the expensive proprietary stuff, because I just I'm not interested in that. That's not where I want to go with it. So I can't really examine somebody else's, proprietary expensive piece of software to determine what they've, pulled out of LaserBoy to put into their thing. But, I've been to, every year there, since I think 2007 was the first one, there's a meeting, they call them LEMs, Laser Enthusiast Meeting. There's a LEM in North Carolina called SELEM, SELEM, which is the Southeast Laser Enthusiast Meeting, whatever. It's in North Carolina, and I've been there. I was there in 08, 09, 10, and 13. So that's really my most exposure to like what other people are doing as far as software and hardware is concerned. To actually be there and see it happening live, presented by the person or company that was, putting it out and promoting it. So, I guess that's, I know also there was a guy that he actually was from Cleveland originally. He's moved now to Oregon, I believe. But this guy in Cleveland contacted me fairly early on. And eventually he made arrangements with me to, I guess, license the core of LaserBoy. And then he developed his own project on top of that called ILDSOS. I don't know if you've ever heard of that before, but it's ILDSOS. And then he also, I believe, used it to develop like a live webcam kind of a thing that does outline tracing. And yeah, it was pretty cool. So I know for a fact other people have used it because I've actually, had an arrangement with them. But other than that, I really don't know specifically. I mean, I know that Ketil Mikkelsen, I'm hoping I'm pronouncing that correctly. I think he's Norwegian. He came up with a thing called what is it? Laser Show Gen, and he includes LaserBoy in his software offering because he uses the LaserBoy font system. So he's using LaserBoy fonts that come with LaserBoy in his application. So that's kind of cool. Yeah, it was LaserCam.
One thing, and some of that LaserCam stuff, I believe, gets packaged or is available as an option for the LSX platform. One thing that happens when you start working with, when you have a commercial company that's starting to develop a piece of software, is that they're very interested in the usability of the user interface, and all of them start to look very much like standard timeline based with menu options they start to resemble every other kind of media production platform, whether that's an audio editor or a video editor or something like that. One thing that you have been very uncompromising about, one could say, is the user interface of this particular piece of software. And for me, it's a bit media archaeological. It's certainly not that nobody uses console applications anymore. I don't believe that to be true at all. But the majority of computer users aren't so comfortable in this console environment anymore. So for me, it kind of looks back to an earlier era of computing where this is what you would encounter most of the time, for example, in the 80s and in the early 90s, which is probably when you got started with some of this stuff. So, I mean, it's definitely also on the forums that I share membership with you on. There's certainly a lot of complaints about the interface, like that it can be a bit confusing, and you get kind of lost in these deep menus and things like that. Have you ever been approached by anybody that is willing to write you another sort of interface for it?
Well, no, not really. I mean, there was a guy in Russia who has his own forum, which had a big part of it is laser, not the whole thing, but a big part of it is. And so like Russia, all of a sudden LaserBoy became this thing in Russia for a little while, which was pretty cool. And he said that he was going to, do that. He was gonna, he said, it's open source, so I'm like, yeah, that's cool. So he said he was going to start with the core of LaserBoy, and he was going to create a mouse-driven GUI for it, but it never really materialized. I have done a considerable amount of work in the code trying to separate the math engine part of it, the memory object and all the functions that go with it, from the user interface part of it, so that it would be, at least a little bit easier for other developers to say, okay, I can just chop this part of the code out and put my own, GUI whatever in here. But so far that hasn't materialized. It's kind of weird. I've never, in all the 17 years that I've been working with this, I've never had anybody who's willing to like jump into the code and say, okay, how does this work? And how can I add to the code? How can I modify the code and make it do different things? And I'd really like to do that, because one of the first things that LaserBoy did that I thought was particularly useful was the ability to start with something that already existed in an ILDA file and then perform some function on it to create something new. You can start with one single frame and use the elements in the frame to create an animated frame set, or you can have a selection of just a few frames and create an effect, or you can put an effect on an entire frame set. And I was very careful in the way that I wrote the code, and the fact that it is very object oriented, and it uses things like, the functions, of course, and it also uses overloaded arithmetic operators. So you can say things that are pretty intuitive, like you can say frame plus segment, and it'll add the segment to the frame. And, so you can use like standard, what you would call infix algebraic notation in math to create functions and code that read rather intuitively. And you don't have to write 100 lines of code just to add two segments together to make a new frame. It's just A plus B. It's pretty much that simple. And I would really
just for a second, James. I'm going to cut in just for a second, so we're not deep diving so deep there.
Okay.
Describe a little bit my interactions with the software, because I think that those could be somewhat of a model that you work on, which is that I had a very specific task. I wanted to render some letters to display actually in another software that I use, Pure Data, on the laser. And rather than finding, let's say, a manual or something like that online, what you come to very quickly is that James is very encouraging of you to contact him directly. And what he's done actually kind of in the buildup for Vector Hack is to start to put a YouTube channel together with a lot of examples of the kinds of things you would do in LaserBoy, with him working through those specific problems, which is good. And that's definitely a vast step upwards in the direction of documentation than what existed, let's say, a year ago when I first started kind of looking, or 2 years ago when I first started looking at LaserBoy. But this invitation for the direct personal contact is very interesting, and you've always been super helpful. But I also wonder if you had more users and more people kind of came into that community, I could imagine that very quickly it's going to become a burden. You could kind of lead yourself to burn out a little bit.
I hear that.
One specific question I had is if the use of LaserBoy requires a lot of, let's say, repetitive key commands, in the same way that the use of some other media software requires a lot of repetitive mouse clicks, to the point where you're getting carpal tunnel syndrome. Is LaserBoy scriptable? Is it something where you could write a script, and if you needed to execute the same thing to 20 things in a batch or something like that you could do?
Well, at the moment, no, it is not. But I would like to do that. I think that would be kind of an interesting thing. And some time ago, I developed the ability to import plain ASCII text in the form of like tables of vertices with colors and whatever. It's kind of like a text version of an ILDA file format, but it kind of goes a little bit further than that. And then just recently, after I had a rather in-depth conversation with you, Derek, you were asking me about, okay, it does these math forms. Is there any way you can animate them? And I was like, presently, no. And then I got busy, and I extended the text import capabilities to now include a whole list of math figures that you can put in like a standard form. You can fill in the coefficients for these formulas, and it'll render them into space. So, and then I extended also the capabilities of text import, meaning, dropping font. And you saw some of that in the video in the little part in the corner of the screen where it was showing the silent video stuff. So kind of as an extension to that, I would like to come up with some sort of a scripting language to where you could, like maybe indicate what frame or frame set you want to start with, and then a series of instructions as to what you want to do with that. And then, and then at the end say, okay, save that as whatever, a wave, TXF, ILDA, text, whatever. Yeah, so I would like to do that very much. So, I mean, it's a matter of the amount of time that it takes to do this stuff. Because I mean, when I have something in mind that I need to do with like extending the math and the text capabilities, I mean, I was working on that like 6-8 hours a day, 7 days a week for, weeks. And, it definitely takes time to do that, especially when you make like a radical change to the way things work. But yeah, I do want to create a scripting, kind of a scripting scenario. I don't know if I'm sure a lot of you out there have probably worked with FFmpeg, right? So FFmpeg is really cool because you just invoke it on the command prompt, and then you include this ridiculously long string of arguments to the FFmpeg, and it does amazing things. And something like that would be pretty cool, almost like a completely headless version of LaserBoy, where you just invoke LaserBoy, whole bunch of commands, hit return, wait, and there, it's done. And you really never even saw any of it happening. It just happened. That would be kind of cool.
Well,
that would definitely
Possibly dangerous attached to a laser, but super cool for generative stuff.
Yeah.
But I want to say that basically I didn't think for LaserBoy that user interface is so strange, because I know that like using keyboard shortcuts and that sort of stuff actually can really speed up your process. I only thought that there is lack from documentation. And right now I checked some of your videos today. I couldn't watch them during the festival because it's simply too many things, but I think they're great. First of all, because like the introduction video of 33 minutes is, you repeat some things, you go over again, but all the time user interface is present on the screen, and as you change things, just to explain what you're talking about, they make more and more sense. So even in these general areas of explaining what LaserBoy is, it's the whole user interface and functions start making sense. And I think you made one very important, I think you said one very important thing about it, that basically you had problem writing the manual because functions keep changing and shortcuts keep changing, but they are just usually one click, the menu with commands is one click away. So it's very easy to access it. So once you see those tutorial videos, even if the functions changed, the general overlay and idea of LaserBoy is clear, and of course some things are geeky and complicated and will be the problem. Well, but that's what we like. But I mean, for myself, some things are like, oh, I like this is great, and some things are, I'm completely lost. I really liked vector order short video that basically similar to what Derek was doing on some recent work that is not out yet. There is X and Y, but the time when something is written is displayed as Z. So when you rotate display, you can see what's drawn first, what's drawn second. I was wondering if would it be possible to, but it's if I would, I don't know if I can import wave file to LaserBoy, but we work in a way that basically frame rate changes. So how would LaserBoy know what is the first frame, what is because actually there are sometimes no frames because there are a few time bases going on at the same time. So
well, the way LaserBoy imports wave, if the wave did not come from LaserBoy, then it does not have LaserBoy formatting, obviously. So basically what you do is you have to tell LaserBoy, all right, how many samples do I want in each frame? And then LaserBoy will chop it up that way.
Okay. So yeah, but that makes sense. Variable frame rate is a bit out of reach for this.
And again, going back to what you were talking about, the vector order thing, if you import, let's say you have the output of some sort of analog abstract console or something. It's probably, I mean, maybe it's going to have some sort of time base to it where it sort of repeats. So like there's a fundamental low frequency oscillator that's controlling like the whole sequence of events. When you bring it in, you do the vector order view and kind of spin it around, and you can go, oh, okay, well this looks like it's repeating about 3.5 times. So then you go back and you adjust how many samples go into each frame. So you can.
It's usually visible in sound editor, any sound editor. If the frame rate is stable, you can just visually see the repeating pattern.
Yeah, and then you can just drop your cursor and say, what sample am I on? And then go into LaserBoy and say, that's how many samples I want in each frame, and it'll import it that way. Another point I want to make about the keyboard interface thing. When you're working with this, you're in 3-dimensional short integer space, which means the resolution of the art that you're working on is way bigger than anything that you could display on a screen in 2-dimensional raster. So, when you're using a mouse on a 2-dimensional raster display, the mouse's resolution is the same as what you see on your computer monitor, right? So if you want to select an object and move it over here, or select an object and rotate it with a mouse, it's kind of hit or miss. You're kind of taking a wild guess. How far am I moving this? How much am I rotating this? Well, with LaserBoy, because it's like a state machine, and it reacts to a single keyboard event at a time, you can say, every time I tap this key, I want to rotate 27.5 degrees. Every time I tap this key, I want to move, 2048 points this way or whatever. So if you know where you are and you know where you want to go, you can get there in absolute arithmetic perfect. Yeah. And you can't do that with a mouse.
I've got a couple more things because Joe Hyde is going to be joining us shortly from Bass Spa, but there's a couple more points in my list of stuff that I wanted to get through here while we still have a couple of minutes with you. Maybe the first one, and I think it's really fascinating to talk about the strengths and weaknesses of different sort of software approaches, and definitely the precision of having text command input on certain parameters. It definitely far beats kind of sloppy mousing around and things like that. However, definitely the most challenging aspect of me relates to one particular aspect of LaserBoy. Now, over the course of the Vector Hack, we've been talking to people from, let's say, different eras of computer art and different eras of video art. And the 60s and early 70s, probably most of the way through the 70s era of computer art, the thing that keeps coming up over and over again when I read accounts of artists from this era is the non-real-time aspect, and people using words like frustrating, agonizing, horrible to describe this, what James Whitney or John Whitney talked about when he said it's this non-real-time aspect is sort of like playing the piano and hearing what you played tomorrow. And certainly in video art, beginning in the late 60s and definitely in a lot of the work of, for example, Dan Sandine or the Vasulkas, the real-time aspect and the ability of the body to interact in real time with the creation that you're making became of the utmost importance. And I think that most of the tools, most of the let's say the advanced media production and media performing tools these days all involve some aspect of this real time and this bodily gestural sorts of things. And that's the part that is for me really missing in LaserBoy, is that I mean my working flow with LaserBoy has been to import things, optimize them as a WAV file, and then export them so that I can work in a real-time environment of my own my own creation in Pure Data, the vector synthesis library. And I see it as a really valuable tool to produce optimized chunks of WAV files that you can then manipulate in real time. However, I would be really hard pressed to find the time to sit down and cursor, keyboard select points in a complicated, 3D form and manipulate them in that way. I would find that really difficult.
But you can.
You certainly can. You can do things lots of ways. I just wanted to bring that up. But maybe my closing point is a little bit of a wider perspective, and this has to do with another area of computer art history, which is that of software art. And for me, like from the moment that I saw LaserBoy, what I saw was a very individual expression. What I saw was something that's very idiosyncratic. It's very media archaeological in the way that it wants to go backwards into certain areas of computing and design history and kind of reenact them in modern ways. And that it very much invites the user into the mind of the creator, into your mind, James, actually, as a way of kind of inviting the person who is using this piece of software into your world. And maybe it's not the most optimized media production tool, but what it is it's its own kind of encapsulated, very self-sufficient world, which I think any sort of good artwork can be as well. And I've always looked at LaserBoy in that way, and it's been really fascinating to interact with it on those terms as well. So thank you for that.
Thank you. It kind of came to mind that I was watching everything else that's been presented in Vector Hack so far, and then there's quite a bit of it is like performance pieces, a finished work of art. And I kind of think, well, I'm not really presenting a finished work of art in the sense that you can watch a video on YouTube, but I am presenting a finished work of art, and it's live. The moment you open the application and start working with it, you're getting your own personal live performance of my art.
Absolutely, yes.
But on last Vector Hack, we were very tool oriented. So basically last year, I think we had more, last time we had more videos where people explained the technical aspects of their work or specific software or hardware tools they're using or that they made. So in this year's edition, it's a little bit different ratio.
Yeah, but there's that combination. I think we try and cross that divide of tool makers, tool users, and people who do a bit of both at the same time. And that's where I think the most interesting thing is, and LaserBoy fits in with that perfectly, where it's kind of this really personal tool, but that lots of other people use it too.
Well, the one thing, in all seriousness, the one thing that I really was concentrating on when I was first developing it was, it was kind of like I was looking at the price of, the cost of entry, so to speak, into getting into laser display as an art form, and I was just, wow, this is expensive, and so I just thought, all right, so what can I do here to make a tool so that somebody can, and I'm not saying that this is, you should necessarily think of it this way, but my thought was, I want to make this so that somebody can get into the laser display, from soup to nuts without having to use any other software, and have some sort of a pleasant experience with it. So you can start with nothing, you can create your thing, and you can output it as a WAV file, and it displays on a laser projector. So no, it's not a real time thing, but it is a way, technically speaking, if you bought a laser projector with an ILDA port to input to control it, and you build yourself the DAC, you either buy the kit for the correction amp from me, or you build your own because the circuit's out there. You can actually use nothing but LaserBoy and your own home built DAC to be able to do a laser show for nothing, basically, for free. So
I imagine that LaserBoy would support other commercially available audio interfaces that do have multi-channel and do have DC coupling. For example, the Motu series. I imagine you could use it with those as well. So.
Well, yeah, WAV is WAV, and and also in LaserBoy you can set the sample rate of the output of a wave. So if you have a sound device that can do 192 kilohertz or even 384 kilohertz or whatever it is, you can do that. And yeah, it produces 6-channel waves, and that's XY and RGB, and then the 6th channel you have some choices there. You could put Z data there if you want to actually have 3D in your wave, or there's some options for putting in variations on a monochrome version of what's going on in the RGB channels. If you have like only one color laser in your projector, because if you just use the red channel, for example, to control a monochrome laser projector, it's only going to come on when the red laser's on, which that's not going to give you anything good. So you can put a monochrome signal in the 6th channel.
We're going to have to wrap you up pretty soon here because we're a bit over time on this particular part. Klif, you had one thing to add?
Yeah, I just wanted to say quickly about standards. We were talking a lot about standards for laser, and indeed on this Vector Hack we had quite a few works that were sent over in different file formats, and basically our kind of hacked waves files from PD played most simply on I have a feeling it really is a solid standard. It's easy to manipulate. It's easy to play it back, and as far as laser manufacturers go, Bernard Ratzinger brought his Solinger laser. He bought it recently, and it has built-in AVB port, which is a network standard for sound. So it shows as a sound card in a computer. It's like we set it up on my old Mac in like 5 minutes, There is really nice control software with like all the security features, masking zone and stuff. And on the top of that or under that, you just play your files from any sound software you want. I was using Max to actually show work by Sofia Udiskaya. And I see it like, okay, there is somebody who makes expensive lasers and like is doing something that is not dependent on their own hardware, that is basically industry standard for audio and for moving data from one machine to the other, which is great. Hopefully others will follow too.
Mm-hmm.
Great. Okay, we're definitely sorry to be the alligator there. We're at time for this. I would say if you guys want to keep talking laser standards and LaserBoy, the chat on the YouTube here, there, I think, or is it there? Or is it there?
There or there, depending on how big your window is on your desktop.
Link somewhere. I would say that the chat would be a really good place to kind of keep that discussion going. So thank you once again, James Lehman and LaserBoy, for joining us on the Vector Hack. Chris.
Well, thank you. Thank you so much for having me. And by the way, how long does this chat for the YouTube thing, how long does that stay open? Because my past experience is when the video presentation things are done, it kind of just
no, it's still there in live chat. You have I don't know where button is in I was using it on my mobile phone, so it's the chat is in live chat, but you cannot put comments any longer. You need to go to comment section. Apparently that's how this works.
Oh, okay.
So, but I think when you watch the video, the comments pop out in time. So basically, when you're at the beginning of the video, there is only one comment, and then as you go forward, the comments keep coming.
Yeah, they get saved.
It's a bit weird, but it's nice.
Cool. We can address that over in the chat.
Okay. Well, again, I would,
because I know that Joe's time is also very valuable, and you've got some other things to do as well. Thank you, James. We're gonna Chris, you're gonna introduce Joe to us.
Joe, thank you so much for joining us.
No problem. My pleasure.
The reason I thought this would be nice is we screened one of Joe's works as part of the festival, but also Joe is involved in his practice in all of the different things that we kind of have as themes of the festival. So we've had a lot of meteorarchaeological stuff and historical things. And one of my favorite things Joe's done is he has a chapter on some of Oscar Fishinger's sound synthesis and score-based experimentations. He's written 2 articles on that. He also works with lasers, Vector X, analog synthesis, digital synthesis, and software environments. So I think like everything that we do and talk about in the festival is kind of encapsulated in Joe's practice. So very selfishly, I thought it would be great to kind of invite you on and talk about.
Yeah, like I say, really nice to be here.
Yeah, and then segue kind of into a little wrap up of the festival, although we've got a couple more things going on after this, which we'll talk about after. So I guess, Joe, first of all, we screened your work in the festival from Signal Culture, right?
Yeah, that's right, yeah.
Which is really lovely. And I guess there's lots of kind of common themes with lots of the other kind of works that we've also screened, but I guess it's not so much a question really. I was just, I thought we had like a really nice group of works from the open call.
Yeah, it was excellent, excellent choice.
Yeah, I mean, I've been catching up with all the streams. Actually, I've been a bit tied up with the kind of university situation here in the UK, so I've been a bit preoccupied this last week or two. But I've been catching up with all the streams over the last couple of days, and I must say, it's an amazing festival, guys. Really incredible, just bunch of talks and work. Pretty much all of it is great, I would say. I mean, I don't know why I have to say pretty much. All of it's great. You know, there hasn't been a single thing that I've not been bowled over by.
It can get very
very happy to be in this company.
Thank you.
Yeah,
there wasn't a question there, was there, Chris? I'm feeling like I didn't answer the question.
Not so much a question, but I guess the other thing I wanted to talk about as well is, of course, Derek spoke at Seeing Sound. I think the last time you did it, right? And that's your festival.
Right, yeah.
And I don't know whether you wanted to talk a little bit about Seeing Sound, and because I think it relates, it's kind of more general in some ways. It's definitely more academic than Vector Hack, but I think there's like some kind of crossover in that it covers this whole range of themes and it's practice-based.
Yeah, absolutely. I mean, I think the thing with Seeing Sound is it's 11 years old now, so it started a long time before Vector Hack, and it had a different function then. I think 2009, I suppose it was. Then it felt like the right time for quite a general festival, and it almost felt like the idea of visual music was new, which of course it wasn't. It was a century old at least, but there was that kind of new resurgence of interest in the States around the Hirshhorn show and the visual music book and the Sonne Lumiere show in the Pompidou Center, and it suddenly felt there's all these people suddenly getting interested in these new practices around audiovisual work. We should do an event and try and find these little threads of things. It's gone with my enthusiasms really, which obviously overlap with yours. So we had a kind of analog video themed one, which we invited you along to, Chris. And the last one had a bit of a vector synthesis theme.
Someone whose work I also really love, who presented at that one, was Rob Mullender.
Yes,
But also Seeing Sound is somewhere where because as you know, like anything to do with audio visualization or visual music and things where there's a complete balance of visual and auditory stuff, I'm super into. So it's not just electronic things. And there's so many interesting things I found through Seeing Sound. And I guess that brings me on to the other kind of thing I wanted to draw out, which was that you're a professor of music and you started in audio composition, but you work a lot with in collaborative ways with lots of other performers, and you also do a lot of audio-visual work, and you engage with kind of these DIY communities online, as well as operating in an academic zone. And I guess that's the kind of landscape. But do you think does for you all of your visual stuff start with the auditory and then it's linked in, or have you moved into a place where they're kind of linked? And I guess that's the same thing I'm thinking about with the crossover of this kind of academic and this DIY space online.
I mean most of it does. I mean, to be perfectly honest with the visual work, I think I feel I need to constantly remind myself of my limitations and that I'm not a trained filmmaker or a visual artist. And if I get a bit too big for my boots and try and do things just purely from a visual perspective, I can sometimes come unstuck, actually, and it can be not very good. I do remember one particular project, won't tell you which one it was, because I'm not very pleased with it, but where I ended up just doing visuals. I didn't do any of the sound. Other people did the sound. And I just thought, no, I shouldn't be doing this, actually. If I wouldn't hire myself just to do some visual material, I'd hire somebody who was better. But on the other... to approach that from the other way, something I do, I suppose, like in my own work, but I really like seeing in other people's work, is where the same creative mind is clearly at work in the visual and the sonic domain. And I still think that can compensate for all sorts of other weaknesses. If I see somebody who may not, be incredibly good at visual programming or whatever, and they're using Touch Designer or something, their work might not quite stack up against, a group of people who that's all they do. But the fact that they're doing the sound and the images, even if it's not such a direct relationship as I see in a lot of the vector synthesis work, but it's a more conceptual relationship, but it's there. That's amazing, I think. And I think that's probably the thing that Seeing Sound and the Vector Hack still have in common, is people who are creating an audiovisual entity on their own, mostly,
And I must say this year's, because I was preparing the screenings and also watching the material in the venues with proper big PA in like nice conditions. and it's amazing how different approaches there are from. I know more or less. I understand and know the methods who works with what, but still from amazement, like how did they do this, or how does this sound make this image, to just plain thought process of like looking at it and thinking about how they approached it, like what was the did they think more about sound or image at that point in the work, because it's always struggle, especially with all the harsh noises that like to come out of this process. And yeah, that's all. That's just
but it's interesting to see how people have evolved that. I must say, I really, I mean, just to sort of go back to this thing about seeing sound being quite general, I really admire the fact that Vector Hack is so specific. It's brilliant.
It's pretty niche.
Yeah, but seriously,
like this.
It's a thing, you know. It's carved out an art form, really. But the interesting thing for me is that art form has moved on as well. You know, looking at the streams in comparison to work that I saw in 2018 or before, that, you know, it has evolved. You know, people are using those harsh sounds that you described, but they're, you know, the range of sounds that they're producing that way, and the range of images is kind of spectacularly much better than I was seeing even recently, you know.
I hope one thing that Vector Hack does that I think Seeing Sound did for me is exposes people to some of the context, and
absolutely,
that then informs their practice. And even if their practice is very material based and maybe not so conceptual, they kind of have some sort of like grounding to then situate themselves a little bit and start to talk to each other. I don't know. I definitely think
I don't know how much sort of historical material you had last time, but I've really enjoyed that this time. I mean, the Scooby Lepofsky talk on Ben Lepofsky was just astounding, really. And to see that work from the 50s, you know, the color oscillons, I mean, incredibly inspiring, but also a little bit sobering. I don't know if that's the right word, but to think actually this stuff that we're excited about now was done to quite an advanced level in the 50s. And it's good to remember that, actually, and not just to reinvent the wheel all the time or feel that you're reinventing.
I think it, in a way, I think it makes me feel more excited. And I think sometimes people are scared that it will de-incentivize themselves. But I sort of feel like I want to do something like slightly different that builds on whatever the legacies were. And sometimes I guess there's a lot of my interest to kind of that media archaeological thing, which I know you've written about, and I think Derek is the same, and Klif as well, where we're sort of like taking ideas and exploring them from past art forms or past artists' practice and past technologies, and bringing them into the kind of present, and then maybe trying to do something a little bit new. Or
I mean, I think it's absolutely fine to do that. You know, I will almost certainly steal some ideas from that paper, for instance, but you know, I'll acknowledge them. And you know, I think so long as you do put yourself in that lineage and sort of see that that's what you're doing, rather than kind of claiming that you've invented something from nowhere. It's fine. And also, you should push it on. And something I've kind of been interested in a lot of my work, which I guess certainly Derek, you at least do, and I'm sure a number of people in the event do as well, is not being at all purist about the analog digital thing, because I actually think the possibilities of combining these two worlds are extraordinary, really, and that's where it's at for me right now. You know, that's where you could do things that Ben Lepofsky couldn't do, for instance. You know,
that's really into the line of questioning that I wanted to bring into this, and allows me to kind of reiterate what I've been saying in front of most of the historical panels that we did this year. was, yeah, definitely, this idea that we're these kind of lone visionary geniuses in our studio reinventing history and innovating is, it's very arrogant to think this in some ways, because we come from a context, and we come from a material context, and we come from an intellectual and an aesthetic context. We bring all that stuff with us. And certainly during the first Vector Hack, we had a few historical presentations on different artists, or we had one specifically on New Tendencies, since that was part of the regional context of Croatia especially. And this year we wanted to kind of bump that up a little bit. But I wanted to bring it around a little bit, Joe, to your work in particular, and the works that you provided us for the screening. Now, the context of those works was of a very specific institution that several of us know. I think actually all of us have been there, that are at least from Klif, and Chris, you've been there. So the signal culture in Owego, upstate New York. And you worked with two very iconic devices there. And both of those devices really epitomize this real-time, physically interactive, signal-based approach towards video, which really kind of kicked off, I guess one could say, with the invention of the Portapak in the late 60s, and the work of Dan Sandin and the Vasulkas and tons of other people in the late 60s and especially the early 70s. Now, the two devices that you worked with were the Wobulator, which is generally credited to Namjoon Paik, and the raster scan manipulator by Dave Jones. Could you walk us through the signal process involved in the use of those two devices?
Yeah, sure. And it's slightly different in each case. And in both cases, in fact, I kept the little description short as to what I used. I did use quite a number of other devices for both pieces, I think, including some digital signals. Yeah. So in the case of the Wobulator piece, I was doing all the kind of vector hack type stuff. I was using signals to produce shapes. They're a little bit different with the Wobulator than, as you will certainly know, at least, Ivan, because I know you built one, which I also saw in signal culture. But they're not kind of Cartesian X and Y. They're more kind of rotational. But yeah, you can still produce shapes that way, essentially, but not from a point. You're essentially able to produce to send an image, a video image, to the device as well. And that's what's always fascinated me about the Wobulator, that you can kind of do both things at once. And that allowed me to do a few little tricks. For instance, there's a bit in the first study that I included, which is the Wobulator one, that a few people have seemed to have been struck by, which is a kind of rotating object. And both of my pieces seem to have rotating objects, but there's one particular one in the first one. And the sort of short story there is that it was actually a rotating object. So in fact, I'd gone to see the, I actually can't remember. Sorry, I went down a rabbit hole that I can't. Oh yeah, it was the Maholinage exhibition at the in New York on the way. Sorry, I've suddenly just kind of lost my flow there a bit. But yeah, I'd gone to see that, and he has these structures, these objects that rotate and work with light. And I'd kind of been mulling that over, really. So amongst all my other experiments with the Wobulator, I did film some rotating objects, as in real life. I honestly can't remember what they were, unfortunately. This was 3 years ago, this one. But then I did do a number of things to manipulate those with signals. And one of the ones, which I think might be the one that people have picked up on, is where I derived an audio signal from that video and fed that in to deform the thing, so that the deformation actually kind of followed the rotation, which I don't think I ever followed that up, but it kind of was a neat trick that worked quite well. I think there is something else in that piece as well, which I do actually use the Jones colorizer, strangely enough, in that. So there are some patterns in there that just sort of kind of stripes and things, where I just wanted to produce these really simple images, again, in order to wobulate them. And I used the Jones colorizer to do that for no particular reason. So I could use a signal to make these simple, I mean, I could have easily done this in Max MSP or something, but hey, I was in signal culture, so I did it that way, just to produce these simple kind of shapes that moved around. And then I'd use the same signals to wobulate them at the same time.
A note for the viewers that you can see these signal culture pieces on the screening stream from Vector Hack for the 4th of October. And Joe's pieces are part of the screening program for that. Moving on to the raster processor. The cousin of the raster processor is a little bit more well-known instrument called the Root Etra video synthesizer, or the Root Etra scan processor, or the Root Etra raster manipulator. The Root and Etra seem to be consistent through all the names. The Dave Jones raster manipulator is a little bit harder to come by. I think there's actually only 1 or 2 of them. And certainly the one that people would have any sort of experience with, they would actually have to go visit Signal Culture, which was located in Owego, New York, and is now moving to northern Colorado, actually, very soon.
Yeah, that's correct. And at the moment is in packing cases, I believe. In fact, I think I was the last, almost the last person to do a residency there. Before that happened, right at the beginning of COVID and all that.
Wow. Yeah, the raster manipulator piece is absolutely beautiful. It's everything is kind of compressed into this strangely 3-dimensional spherical shape that actually reminded me quite a bit of these slides by Aldo Tambellini that were shown in the Tate Modern that I got to see in February. Actually.
Oh, I know the ones you mean, yeah.
They had this lovely series of these little circular shapes that when they projected, on the wall became planets, basically, like moonscapes and things like that. And there was a lot of planetary moonscapey things going on in the raster manipulator piece that we did.
Yeah, well, I just sort of evolved the
digital in there as well.
Yeah. So I was actually the sphere in its original form was generated digitally. In fact, again, as an image to feed in, but then with analog deformations of various kinds. So I was combining those two things. I'm pretty sure you could generate a sphere fairly simply in analog world, but yeah, that seemed the easiest way to do it. And I just particularly with that one wanted to focus on this spherical form really and kind of stuck with it. Weirdly enough, I was thinking about viruses actually, although it's ended up more planetary. I think that's for sure. It's quite hard to capture the output of that device. I think I've been interested in seeing a few other versions of that in the festival. Paloma Kopp had a piece produced on that.
Oh,
and
she
yeah,
had excellent captures.
Yeah, really.
She had excellent captures. Paloma,
she did.
You can see that she does that for a living.
Yeah.
Stuff.
Yeah, I don't think my capture of that was quite as good, unfortunately. Although she put hers in black and white, which I did wonder whether to do that, and I still might. I kind of think it looks better in black and white, maybe.
It's a difficult kind of choice, isn't it?
It is really, yeah.
I don't know if it obscures some of the source, the like rawness of the source, but at the same time, it does like up the contrast somehow, or makes it easier to discern some graphic elements.
Yeah.
I often wonder.
I mean, I don't think I've got that one quite right yet, actually, which is just it needs some really careful kind of grading, I think, which I've been working on, but it's not. It could be better, I think. Anyway, that's getting a bit too kind of whatever, isn't it?
Coming out of the specific technical details of those pieces, which are, of course, really wonderful to hear about, and I think help you kind of get some transparency into the work. A more general question from which perhaps a bigger springboard can come out of is this: what makes using these pieces of equipment from the late 1960s, the early 1970s, how is this relevant? Why do we return to these iconic devices over and over and over again? And are we are we moving forward with them? Is there something new to say with these old devices?
Yeah, I mean, I really think there is. I mean, this kind of obsession of combining analog and digital is something that I do a lot of, and I do a lot in the audio domain. So maybe a good example of this is actually to talk about something that I do with audio, which is I work a lot with very niche tunings. Actually, I'm very interested in esoteric tunings or just temperament, this kind of thing. And it's very difficult to really do that in the pure analog domain. You just can't really get that level of precision. So I've built a system basically where I use Max, could as easily be PD, to track the pitch of my oscillators and to tune them in real time. So I can keep these oscillators just absolutely perfectly on these harmonic ratios. So everything that you hear is entirely analog. It's just the sound of my modular synthesizer, but it's being kept into this perfect tuning using a digital system. And I suppose the thing I should say about that is part of me thinks that's really pointless, but another part of me thinks it's great. But actually what's really great about it is that it doesn't always quite work. And I gradually realized that's the best bit. So most of the time my tuning is spot on, but every now and again it does these weird kind of wobbles, which could only happen this way. You get the kind of some kind of glitch happens in the digital domain and all my control voltages go off. But then the analog oscillators react in a really interesting way and kind of then gradually get perfectly back again. And I don't think I could produce that sound any other way than with that weird and slightly wrong and homemade combination of analog and digital. So yeah, I think that's where the new things can be discovered. And I see very similar things really in, again, what Derek's doing with PD and the Vectrex. Again, sort of something that you could do in Touch Designer or in open frameworks better in a way, but by doing it on the Vectrex, you get this just kind of, texture, this painterliness that is magic,
It's funny because in Andrei's talk, he was a lot about microtonal or non-standard, non-Western tunings.
I haven't got up with that one yet. I'll have to.
With your no, but I think you'd like that one. But with your audio stuff, does it also allow you to do things like FM in the analog domain while keeping these very fixed tunings, so you can kind of inject other signals?
Yeah, absolutely. So there's something that I haven't actually kind of completed yet, but I'm working on, which is essentially a kind of very John Whitney-esque exploration of harmonic series in circular space, in polar space, and using FM synthesis between harmonically related sounds. And yeah, you'll see it soon, hopefully. But the same harmonic ratios are very clear in the sound and in the image, I think. And again, I know this is something that Derek, you've written about in your vector synthesis book, that really a lot of the interest is actually about the relationship between tones rather than the tones themselves. And those relationships are what make the coherent images that we know, whether it's X and Y. If the X and Y signals are harmonically related, they will often produce something much more interesting than if they're not. And I'm exploring the same thing, but just as I say, in circular space. And again, the circular space is much easier to do in the digital domain than in the analog domain. I've actually talked to you about this, Chris, haven't I? And you've given me some pointers as to how you can do it in analog world.
Analog Cartesian polar conversion. Wow, yeah. that does sound pretty wild. Yeah, this tonal relationship stuff was actually quite a bit of Andre J's talk as well, and he's written this tool called Phosform that he uses to explore those kind of relationships. And again, this is kind of a digital. Oh, it's definitely much more of a digital tool. It's a digital hybrid, but actually his output is generally video projector. Of course, we would be quite remiss in not mentioning Klif's RE We're Here software as well. as one of the crossover
Unpronounceable.
analog digital things. I mean, basically using digital technology to emulate earlier tools, so the root etra synthesizer, for example, and emulate them in a way where you could get the same sort of output. You could output it to a vector monitor or to an oscilloscope with a brightness control or something, and get that really gorgeous phosphor analog sort of output that is really quite challenging to emulate on a screen. And also, and I talked with my workshop students quite a bit about this. Is there really try to emulate a phosphor analog oscilloscope on a screen, on a computer screen?
Yeah, I mean, I don't think you can really. I mean, again, sometimes these things are kind of by accident, and they real kind of serendipitous stuff. I know one of the very early things I did with my Vectrex, I made an absolute rookie error of not cleaning the screen. It had a filthy screen. And I did this for a band, actually. I made a video for them. And that was the bit they liked the best. They really, because it just, it was proper dirty. I think I just got one off eBay and hadn't. And actually, the way the light was catching all the stuff on the screen kind of looked amazing.
Oh, no, I've made that mistake myself. A number of times you get some grubby something that the camera sees that you never would have.
Yeah, that's right.
Yeah, totally happy or sometimes unhappy accidents.
Yeah. Well, they can be unhappy too, of course. Yeah.
One thing I kept looking at in the various live sets or the various pieces from the screening is, of course, how many people have this hole burnt out in the very middle of the CRT.
Yeah.
You kind of see this happening over and over again as kind of the natural evolution of these things doing these kind of graphics, is that eventually you burn out the phosphor in the very center of the thing. And
yeah, I've definitely had to devise a few forms just to miss that hole, just.
Derek, you were talking like asking if you think if there is new things to be done with these tools, and I think the something I realized basically coming to Signal Culture, also checking out the Experimental Television Center, some works from there in history, is that basically there are very unlike analog audio with synthesizers, which is like everybody know everything about it or many things. With analog video, is like those are very few tools. People couldn't have it, and like coming to Experimental Television Center for a week or 2 weeks, you wouldn't be able to understand the complicated concept. So there, I feel that in this era, when basically it's technologically dead technology of CRTs and those things, there is people do excellent works because they finally have critical amount of artists who understand the tools they want to work with, which was not the. I mean, you see very clear difference between works of Vazulkas or Gary Hill with the Rat Tetra, which like, okay, this is some complicated stuff, and like they know this shit. And on the other hand, looking at Experimental Television Center archives, many works are similar, which is fine, because you have a week or 2 weeks and you basically don't know how to work with it. They show you a little bit, oh, is our stream dead?
I don't know, something changed.
Something changed.
Yeah, I was just checking that myself, actually.
Is there sound on the stream? Wait. Oh, there is sound. There is sound, but Zoom is for some. Okay, I'll pop out of Zoom and pop back in.
Something changed.
I don't know. So we have sound, but we don't have image. But maybe we should just like go with that. Oh, here we go. We're back.
Okay, cool.
Wow, we've got quite a full house here now. We've got
okay.
Klif, Hansi is in the space as well. Hello, Hansi. We'll be chatting with you briefly about what you've got planned for us a little bit later as well. And James, I think we were trying to get your animations kind of up on the screen there as well, and we weren't quite so successful, unfortunately. But Joe, you obviously you didn't have time to look over all the presentations and all the performances, but one of the things that we wanted to do, since you're let's say a very established organizer of a long-term audiovisual media arts event, was we were going to ask you a bit to take the position of the respondent and to kind of give us your synthesis of what it was, some threads that you might have noticed that maybe we didn't, or some things that struck you about the trajectory of what you saw.
Well, I'd be very happy to do that. I mean, I might need to look at more of it before I could give you a really intelligent kind of answer. I mean, I think I already have to an extent, which is
I think we've covered
being aware of this evolution of the art form. The other thing I wanted to say, though, which is, again, from my experience organizing things, is just, I don't want to kind of, blow smoke up your asses too much, but honestly, it's such a well-organized event, and that really comes across. It's the production values are just incredible, really. And I've been to a lot of online conferences and events over the summer, and a lot of them have not really been very successful, I would say. And it seems to me that just as something aside from this art form, really, you've actually made a really good go of a virtual festival. And I really have to give you some kudos for that. It kind of works. I can tell people are engaging with it. Everything's really well presented. Just even the quality of the chats in the YouTube videos. It's really interesting being able to see those after the fact. It's kind of frustrating. I can see all these comments coming in, but I can't join in. But it actually, I mean, I suppose the interesting thing, it adds something in a way. There's no way in real life that you'd be able to quite have that conversation going on while work was actually happening. It would be a bit kind of rude, really.
Something I didn't realize, that in 2018, when we ran the festival for the first time, it's quite small. We sometimes had like 200 people a night watching performances and talks, but the putting the videos online later on opens up this whole other audience. And Klif is incredibly hardworking, and he's very good. Across, he's very, very good at also not making you realize the extent of stuff that you're working on.
Right.
And
that's a skill,
slowly, iteratively, we added all of this online stuff, and it does open up the festival to lots more people, not just who are watching now in the live stream, but also people can check back and watch things that and use it as a kind of research resource, which I didn't.
Well, I mean, that's an incredible thing that you've got now. You've just like that really got this amazing body of work. I mean, which is quite digestible as well, I would say. It hasn't been difficult or a chore for me to be going back through this material slightly after the fact. I've actually found it really engaging and, user-friendly.
I think in the end, like with all this COVID corona situation, it was scary at first. We didn't know what to do, how to do it, but we really managed to make a thing that works online and in the venues at the same time. And I think the lack of live content, which was kind of also production decision or COVID decision, so that basically we asked people to produce works, and most of these artists are not filmmakers, so we kind of forced them to make concentrated, basically mostly it's live, recorded live acts, which are actually in the venue function or online as really short movies. I'm not sure of how to call them, but it's I think it's great asset and great value, and it made program in the venue very exciting, having like 2 films or 2 videos, and then a live performance, and then another one, then another live performance. It worked very well for the audience. It was much smoother rhythm than like when first year we started to try to fit like 4 performances in one evening, which was it would drag for hours because we were late with everything. And also with talks, we realized that it will be probably hell to try. I mean, even like this, we have tons of mistakes and errors. But if we tried to do live talks of everybody, it would last for hours. Like this, it was much more work for people because they had to edit and think and record in advance. But I think it's great. It was a great decision. And Then Derek and Chris really insisted on having the panels, which was excellent. I haven't been part of that process so much because I was busy in the venue, but what at first it seemed to me will be like a short talk after the video has grown to a full-fledged panel with like nice questions in chats, and
just abused everyone's goodwill.
Yeah, but it's I think I'm actually thankful in a way to pandemic, because it forced us to make a better program that works for not always in the same measure. Like watching panels online locally is not extremely attractive, so we had few people on those things. But overall, it's a great package, and also everything is finished. Last year we were dealing with editing videos for a year. Like this, it's done. It's finished. It's online. I mean, now we can maybe make some articles or think about what we did and like what goes where. But yeah, thank you.
Well, I hope there will be another Vector Hack, and I hope I can be there in real life.
Yeah.
But it would also be, and I do hope myself that we don't just end up living the rest of our lives on Zoom. Yeah. But I do think that we probably can learn something from this experience, and when we go back to doing things more in real life and less behind our screens, that we can preserve some of what's been good about this. Because I've really honestly been, it's made me think a lot looking at this, and genuinely I've been to some big conferences over the summer, and this has been actually the slickest operation I've seen, really.
Wow.
You know,
from the inside it didn't seem like a sleep.
Yeah.
You just blew Clif's mind. I saw the smoke come out.
I think because we're so integrated with the community, already relying on a lot of goodwill, it's easier to do this type of stuff quickly. And it has made us think a lot more about accessibility and openness, and also trying to move towards diversifying who we ask and where we find people, but also who can access all of this information once we put it online. As I say, I think
it's also diversified the kind of people we've had involved. When I wrote up this chapter in my book about the first Vector Hack, one of the points that I really made at the end was, we tried very hard in the first year in particular to try to get it very gender balanced, because sometimes in these very techie audio visual scenes it's not very gender balanced, and we're again looking at an all male panel right now, which only kind of reiterates that point over and over and over again. So we worked on that point hopefully a bit in the first year, but I wanted to push that more for this edition. And also geographically more diverse. I mean, again, it's very focused on Europe. It's very focused on some kind of centers of things in the U.S. And I don't want to go and make a checklist of who wasn't male or who wasn't in Europe or who wasn't in North America. But I think it at least opened up the possibility that people outside of let's say a certain kind of arts and tech elite have a way of participating in things, either as participants or as an audience. And
well, I would very much encourage that approach. I don't think you need to be ashamed of who you are. The people who are core to this community are the people that are core to this community, but one should always be trying to diversify, I think, from that. I think it's good for everybody. It's good for the people being brought in, but it's really good for the community and the scene to reinvigorate itself.
I like the sort of challenge of finding new people wherever and whoever they are, kind of practicing in this way. And I think one of the fun things is when we begin to look at who to invite or connect with in the community, is kind of like going and finding new works and new people I've never seen before.
Well, there are lots of new people engaging with this, aren't there? As you certainly know, Chris. Both the sort of Vector Hack community and the sort of signal culture community have kind of snowballed, haven't they? Really, almost in that order.
Deborah and Jason, and then there's loads of other kind of active people who are kind of building those communities out there, like Coaxial in LA. all of these like other spaces and kind of like little hubs where people are kind of like showing works or creating some kind of community. Pretty nice.
Yeah, absolutely.
Maybe we've kept Joe for quite a long time after we said we would.
Well, that's all right. I'm fine with that. But yeah, and yeah, thanks for inviting me to say. It's been great to be here today, and I'm sort of on the one hand kicking myself I wasn't able to be there commenting on the YouTube videos for a lot more of the stuff, but actually it has been perfectly possible to experience this event to an extent after the fact, and I've been really, really enjoying doing that, and I will certainly continue to do so.
And
I've seen every last bit.
I hope that we can all meet in person in the future, which is the one thing I've missed this year.
Yeah.
One element that I've missed this year.
No, well, I would really like to do that.
Cliff, we owe you so many drinks now. I mean, just like the drink tab is just, you're going to be drinking drinks for the next like 6 years.
Your liver is screwed.
I must tell you, I miss you too, because it's in Rijeka it was pretty busy. Alberto was there, Bernard and Philip were there, Branimir and Hrvoje. And like then in Ljubljana it was only Croats, and now it's only Branimir and me in Dubrovnik. So it's kind of now first maybe you were looking, at the venues like, oh, big thing is happening. And now I'm more looking at the stream and like, oh, everybody's there. But really, like the crowd is shrinking because of COVID, and also it's smaller cities, so it's kind of a natural situation here.
But yeah, I wish I could have experienced some of the things that we've streamed or premiered online from the physical performances, because they've looked amazing. And
Rijeka was, and also the Rijeka 2020, because like the whole thing fell apart and then got back together, but like with 10% of personnel. So big shout outs to Bernard and Sonir, a producer and I think technical director, who were basically did all the work themselves. Like they just, I thought like, where are the workers? And they would clean this huge hall, remove the barriers that were there for some other exhibition. And I was very lucky because I was also on the edge of my abilities, and that to get such a great team there. And I'm even thinking of asking them to join us because they're such a hard workers.
Whenever we whenever we're back in the same room again. I felt quite sad that I wasn't going to go down and get a little Adriatic sunshine before nestling into the Scandinavian winter.
We had all the different plans for Vector Hack and they changed radically from March when COVID started, and because Dubrovnik was first meant as pre-program or post-program of Vector Hack, that would be kind of basically for media to get the ball rolling. Derek was supposed to come, and then now with COVID and also financial situation changing, then we put it as a part of the main festival also in order to save funds. I must say that I feel kind of stupid because I performed 3 times at my own festival, or no, 2 times. But it's and also Hrvoje and Branimir performed a lot, but that's the way it is. And also one thing to tell, we are so lucky because like Hrvoje Radnić started working with oscilloscope, I think a little bit before pandemic started. He got interested in that. I know him for a long time. He's a musician, but like and sound recordings for movies or sound mixer, but didn't do any visuals. And then he started posting these wonderful videos to vector synthesis. And like, okay, we could invite Hrvoje because like I always felt bad that it's only me from Croatia. And I also called Branimir, who's just preparing jumping up and down a little bit for tonight's concert.
Nice.
He's 29. I know him for quite a while. He's now studying at the Academy of Fine Arts, finishing studies, but he did his first performance and it was like looked excellent, and like I said after the performance that it was the best visualization of sound on this year's festival, which is amazing for somebody who does it definitely for the first time. So yeah,
that clip to my workshop students for Vasulka Kitchen. Actually, I think that actually that one and the laser piece, Dirk de Bruyn's laser piece, those are both really good. If I wanted to show one little chunk of thing that I think represents two really good sets of possibilities, I think that those two, they just happen to be next to each other, and they were just great. I mean, I agree very much where Dirk has taken this laser thing. I've been looking at his posts mainly on Instagram now for the last year or so, and just really impressed with his level of tech. And Branimir, I mean, he was an absolute unknown factor. Because I don't think he's posted anything in any place that I've seen it before.
No, he didn't.
Yeah, sure,
very
great.
nice stuff.
He really rose to it. He really came up with some really sharp-looking stuff that stays very true to the medium, to the format of the medium, and what you can do with this direct expression of sound and image from the same signal.
Yeah, I borrowed him oscilloscope beginning of summer, so maybe he did some little test before. For me it was also unknown. I didn't have any time to check with him, but he rehearsed a lot in Rijeka after doing his workshops, and he also did great workshop with people in both in Ljubljana and
with the Phosphorm.
Yeah, and it's
amazing.
Phosphorm looks better on scope than on visualization, but on the other hand, with HDMI out, it's really good for workshops, and it's cheap, which is great also.
Yes, exactly.
But talking about emulations of oscilloscope screen, I think we can pass to our last guest, Hansi Raber, who approached me like we were talking about Vector Hack, and he said that he might come as a guest, which he didn't, but like 5 days before the festival, he sent me a link which said, and it was just a moment.
Click me, it said.
No,
like
it says
computer virus. It says.
Click me. It said VHSASDFG.me. You will see it now on your screens when stream comes up, and it's emulator, oscilloscope emulator that runs in a browser. Apparently, he took some other people's code to pack it together, which is completely irrelevant for me. What is relevant is that it accepts live audio stream from some other artists, and you can see oscilloscope in your browser. Link is already active, but then basically during last 3 or 4 days, we kind of decided that it would be a nice ending of festival, because one of the big problems when we talked about what to do in COVID, we were talking about remote performances. Then there was idea to stream video, of course, which I had to cancel because there was no good connection in the concrete hall of Export Drvo in Rijeka. So we decided to drop that, and we were missing this live thing. And finally now I will pass the word to Hansi, who is then curator of this evening program, which is called Hansi Presents.
Hey, Ivan. Hey, thanks for inviting me. Yeah, I'm sorry. Of course, with me, it's always a mess with the calendar. I don't think I understand it well. So on this website, I mean, Ivan already mentioned it. It's vh.asdfg.me. And the idea is that it really uses this sort of fact of oscilloscopes, that the sound and the image are made from the same signal. So we send only the audio stream, and then in the browser, the oscilloscope is simulated with a very nice emulator by, he's called Neil Tapan from Czech Republic. And then you get to play with all the settings like on an oscilloscope, like the intensity and the size and the colors. And we will stream 3 very short performances of 10 to 15 minutes each. And it's going to start at 9. And I think that's pretty much it.
And no, you didn't say who will perform.
Right, which is very important. So there's going to be Lena K, which she's just, oh, something happened. She's just playing around with oscilloscopes since not a long time, but I think it's going to be interesting. Then there's going to be me. And I don't know what I'm going to do yet. I still need to prepare, of course. And finally, there's going to be Cherubim Fenderson with, I don't know what he's doing yet because he also doesn't understand calendars.
Okay.
Excellent, Hansi. I think it's really nice. I look forward to seeing what this kind of like way to present work live is like. I think it's going to be really cool.
Yeah.
Okay, I must say I messed up that link for the tonight's stream because I clicked the wrong link when starting this talk. So I think I'll have to make another one.
Yes,
we will relay it in the comments and everywhere so that you can follow it. But anyway, you can really go to the. I even prefer if people watch it directly in browser because then they can play with everything. And I must say, this emulator is. I think it's spectacular. It does everything. It does the little wiggles. It does glow. It looks. No, I mean I spent so much money on this gear. I will not say the emulator is good if I don't think so. So it's really excellent.
Yeah, it's a price.
Very cool.
Precise.
So yeah, we say goodbye, huh?
But Klif, just to make it clear what you were saying is we're streaming the performances to YouTube and you'll be able to find a link on our channel and there'll be a chat. But if you want to go to the URL, you can directly play with the tool while the performances are going on and see how it works.
Yes. Yes, and I think
stay and hang around with us in the chat too.
Yeah.
Please.
So shall we wrap it up?
Yes. So I guess I just want to say before we wrap it up, thank you to Hansi and everyone who's performing. Joe and James, thank you so much for joining us.